Hello, I'm Benji. I'm a epidemiologist based at the BSU. And so yeah, I'm going to be talking about whether we need effect estimates. So if we rewind the clock 25 years to the turn of the millennium, epidemiology was going through a bit of a replication crisis where kind of premier large-scale epidemiological studies were failing to predict the outcomes of clinical trials. And this resulted in the editors of the International Journal of Epidemiology writing an editorial saying, is it time to call it a day with epidemiology? And there were kind of two broad responses to this which emerged in the literature. Firstly, the editors themselves, George A.V. Smith and Shah Ibrahim, kind of said, well, the issue with standard epidemiological approaches is that they lack randomization. And so to kind of prevent failures of replication in the future, we need to find cases where there's randomization occurring in nature, and therefore the design of an observational study will be closer to the design of an RCT. The alternative approach, which was pioneered by people at Harvard, says it's not necessarily the design of observational studies, but how we analyze and think about them that's going wrong. And we need to think more clearly about how to line the quantity that we're estimating in an observational study with the thing that we want to estimate from a clinical trial. So the kind of paradigmatic, aparadigmatic natural experiment is Mendelian randomization. So in a clinical trial, we'd randomize someone to an intervention, which typically will vary protein levels or a control group. All proteins are coded for by DNA, and the inheritance of genetic variance is random. So the intuition in Mendelian randomization is if we know which variants modify protein levels, looking at people who've inherited a variant or not inherited a variant is analogous to looking to people who have been randomized to an intervention or not randomized to an intervention in a clinical trial. Target trial framework, on the other hand, says what we really need to do is think about what we're estimating. So Miguel Hanan wrote this, I think it's a brilliant paper called Epidemiological Methods Are Useless, They Can Only Give You the Answers. So what we need to do is think about what the questions we're asking in epidemiological analyses are, and make sure that we align the causal question to the estimand we're estimating. And one requirement for having a meaningful estimand estimate is that the estimate's well-defined, so that there's an unambiguous definition of what it means to be exposed or unexposed. And the tension between the two approaches occurs because MR estimates, when they are scaled in terms of a unit change in the exposure, are not necessarily well-defined. So to give an example, there are genetic variants which affect the metabolism of nicotine. And so people with these variants will need to smoke quite a lot more to get the same effect of smoking. And so if you are a smoker and you have these variants, you will smoke 2 or 3 times more cigarettes. So if we imagine what the kind of excess smoking due to having these variants are, which is what this graph at the bottom is showing, at the time before anyone's really smoking, there is going to be no excess smoking because no one's smoking. Then as the prevalence of smoking increases, the excess smoking due to having these variants will kind of peak, and it'll slowly decline as people quit smoking or smokers die. What this means is that if we're interested in this estimating the effect of, say, smoking on lung cancer, there is no level of smoking which corresponds to being in the intervention arm, i.e. having an effects allele, or in the control arm. So this means that the estimates are not well defined, and Miguel Hanan on his faculty website, old faculty website, said that this is not a minor limitation with the approach. And so some people have said Mendelian randomization is pointless in the sense that it's not worth performing because it doesn't give us meaningful estimates. Steve and me have instead been arguing that MR should be pointless in the sense that we shouldn't be aiming to get meaningful point estimates. And so the rest of the talk, I'm really going to be talking about whether estimation is that important in epidemiology. And I think the starting point is this short story by Borges, in which he asks us to imagine a king who, for whatever reason, decides he really wants to have a perfect map of his kingdom. This might be quite useful for taxation reasons. It's good to know where everything is. But the issue, especially pre-digital maps, if you have a perfect map, it's going to be massive. And so it's not actually going to be functional if you want to use it for navigation. And so I think the lesson from this is that the amount of detail you need in an answer depends on the question you're asking. And there are some questions that require less detail. Specifically, if you're doing a hypothesis test, this can require less information than producing an estimate. So stroke recovery is a highly multidimensional outcome. If we were to come up with a true quantitative measure of stroke recovery, it would have to combine kind of physical recovery, psychological recovery. It's not obvious to me that we could actually come up with a single dimensional quantitative measure which would capture all of this variation and therefore be able to produce an estimate of what an intervention's effect on stroke recovery is. But this doesn't stop trialists from assessing the effect of interventions on stroke recovery. So a very widely used measure is this two simple question outcome, which basically says, do you need help doing everyday tasks? And if no, do you feel fully recovered? And this gives you a kind of 3-level ordinal outcome, which we could assign each level a number, 0, 1, 2. But having 1 on this measure doesn't have a deep meaning in the same way that having a BMI of, or weighing 10 kilograms has a meaning. But that doesn't mean we can't assess test hypotheses about interventions with it. And likewise, we in epidemiology tend to focus on kind of large-scale phase 3 trials where the aim generally is to estimate a well-defined causal parameter. But not all trials do aim to estimate well-defined parameters. If we look at kind of phase 0 and phase 1 trials, these are generally aiming to assess whether a mechanism is relevant for an intervention, for an outcome, or if the intervention is tolerable by humans. So this is kind of close to doing a hypothesis test. So maybe what's going wrong is when I introduced Mendelian randomization, I kind of compared it to a phase 3 trial, and maybe that's the wrong analogy. So an alternative design is what's called an encouragement design, where rather than randomizing someone to a change in the exposure level, you randomize them to a nudge, which changes the kind of liability of the exposure. So rather than saying, I'm going to randomize you to quit smoking or not quit smoking, instead of you randomize people to receive social support to help them quit smoking. Some people will quit smoking, some people won't. And this is arguably closer to an MR study where genetic variants typically have kind of quite small effects. And so it's not that there's a kind of deterministic relationship where the exposure is going to change, it's that it changes the liability to the exposure. Even if the encouragement design doesn't produce a well-defined effect estimate in terms of the exposure, it does still let us test hypotheses about, say, the effect of smoking on an outcome. And we can do something similar with Mendelian randomization. So there are genetic variants which might affect the metabolism of carcinogens. And so we could use these variants if we're, say, interested in the effect of a specific carcinogen or smoking via a specific carcinogen on bladder cancer. We could use these variants to assess the effect of smoking, even though, because the variant doesn't associate with smoking, it only associates with the metabolism of the carcinogen, we couldn't even produce an estimate scaled in terms of the effect of the smoking per se, or numbers of cigarettes. So we can use Mendelian randomization to test kind of mechanistic hypotheses. At this point, I kind of want to take stock and maybe give a bit of a defense against what have been common pushbacks to this thesis. First one being generally hypothesis testing has been unpopular in epidemiology because of kind of well-known limitations with null hypothesis significance testing. The paper at the bottom is a kind of history of the development of Bayes' theorem, which kind of makes it pretty clear that Bayes' theory was introduced as a way of doing hypothesis testing. So null hypothesis significance testing is not necessarily the same as hypothesis testing, vice versa. Likewise, most historical and philosophical analyses of what science is trying to do couched in terms of testing hypotheses to get at truth, or something similar to that. A second pushback is that trialists actually aren't really interested in hypothesis testing. They're just interested in estimation, and that the MR people who say whether they're interested in hypothesis testing kind of generate a fictitious story about what trialists are interested in. And I think this quotation by Richard Peto, 20 years before MR was introduced, is quite a good rebuttal to that. So he says, we're not trying to provide exact quantitative estimates of percentage risk reductions in some precisely defined population of patients. We're simply trying to determine whether or not some type of treatment produces any effect on mortality. So this sounds kind of like a hypothesis test. It's definitely not saying that he's trying to estimate a well-defined parameter. But maybe, and this is, I think, what I find interesting with hypothesis tests, maybe I think what he's actually trying to say he's interested in doing is some form of fuzzy estimation. He's interested in an estimate, but not a well-defined estimate. The issue with non-well-defined fuzzy estimation is kind of formal methods tend to assume that things are well-defined. And as statisticians, we kind of want to use statistical formal methods. And so kind of defining formally what you need to do to estimate something fuzzily is then a whole can of worms. One thing we do in our paper on estimation in MR is we point out that one of the nice things with a hypothesis test is you can use this to define certain characteristics you'd want from a fuzzy estimate and give you a framework for thinking about fuzzy estimation without needing to necessarily define fuzziness in a formal setting, which to me seems a bit contradictory. And then finally, Miguel Hanan says that people often think a limitation of the target trial framework is that it can't answer yes, no causal questions. And he says, well, this isn't really a limitation, it's just not something the method can do. But this isn't actually a limitation anyway, because epidemiologists aren't interested in answering yes, no causal questions. I don't think that's true. Done my own research, it does include N6. Is it a relevant mechanism for pulmonary hypertension? That's a yes, no question. And I think kind of hypothesis testing as a broad framework has quite a historical lineage of trying to answer these questions within epidemiology. So Austin Bradford Hill, who was Peter Armitage's predecessor as director of the BSU, introduced his so-called criteria for causal inference, which aren't really criteria, they're more different perspectives in which you can weigh types of evidence to think about whether a causal hypothesis, and he was interested in does smoking cause lung cancer, whether there is a causal causation. And kind of more recently, this is really, I think, brought together in the triangulation of evidence framework, which says that to answer causal questions, you need to integrate evidence from multiple different sources with complementary limitations and strengths. And it's through this kind of qualitative synthesis that we will be able to answer kind of important causal questions. So I thought a good place to end was this quotation from John Kay and Mervyn King. We should not give up on modeling or the use of mathematics in decisions. Rather, we should recognize what models can and cannot do to illuminate a problem and accept there is no standard spreadsheet framework which can answer the question, what is going on here? What is going on here? So to conclude, well-defined estimates are useful, but we don't always need them. Thank you very much.